Hi guys, welcome back to a new tutorial of a navigation stack for ROS2 version Nav2, and in this video we are going to see how to make a navigation stack using a turtlebot3 version, and we are using a bring up navigation tutorial package. So using that we are going to move the robot from A to B location in the turtlebot simulation. So in this tutorial we'll learn how to make the navigation stack in ROS2 version of Humble, and before that we see in previous videos how to make in cartographer mapping and another also like a slam toolkit box using a turtlebot3, how to make the slam using those two algorithms, and we make the grid map for the navigation base. So in this video we are going to launch the turtlebot3 simulation. I already launched the simulation, and we'll start with the navigation package. So I already write some Notion documentation for this. So here first we need to install this navigation package for our thing. So sudo apt ROS Humble navigation 2. So enter the password. Already installed, but it will be take some time. Some network issue will be gone, or network speed. So after installing this, we need to install the Nav2 bring up navigation package. So next this line sudo apt installed Humble ROS2 bring up. So this package will be installed on opt shared area. So we'll install this. So after installing the two dependencies package for navigation, we'll start with this navigation stack of ROS2 version, and I already launched this simulation on my new terminal, and I'm going to launch this ROS2 launch nav2 under bring up.py. So and the user sim isn't true, the default is true, and the auto start is also true. The map path we give from the home in home directory, the map.yaml is available. So enter. Okay, after launching this node the slam node, a navigation node, we need to open the RQT to visualize the nodes which is connected by one another. So I am opening a RQT. So from here you can see the turtlebot scanner, laser scanner, and then from the laser scanner we getting a volumetry to get the tracking the location of the robot. So then we using a local class planner and global class planner. So from that the behavior server is connected with the CMD well. So behavior servers and trees structure framework in the ROS2 version. So and then going to map server. From the map server it's going to the AMCL or Active Monte Carlo localization to be part in the localization part. Then it's going to the global cast map and local cast map. So this flow is going to happening. This is for the navigation too. So it's like a behavior tree, behavior planner, a behavior planner tree, control server, a smoothen server. So these all are the packages or nodes available on the ROS2 version. So then we launch this, but you can see some error is going on the terminal. So timeout for waiting for the transformation from the base link to the map because available TF error, invalid frame ID, the map passing to the transformation argument around. So For debugging this problem, we need to launch this command line like ROS2 run ROS2 D, the package pre-build, the package which we launch in for navigation in ROS2 version. So the ROS2 package for navigation is Nav2 under bring up, and then share those information which is we are going to visualize on the ROS. Okay, so we'll launch this. So it will launch ROS with a map of the turtlebot3 environment. So then we need to initialize the robot location. So robot did not find out the exact location of it, so we need to post estimate the robot to initialize the location of the robot. So the localization part, so go to the 2D post estimation and then gives the exact location of the robot area. So now the robot is initialized in exact location in ROS and also in the gazebo. So now we can identify that the localization part is done, and the robot can identify the where I am. So the initial position is identified by the 2D post estimation thing. So then using this, first we identify the location. Now once again we can launch the RQD after closing this terminal. So now I am launching the RQT. So now you can see the previously only this some nodes is connected, but now the plenty of nodes is connected one another. So the cast map server, so these many nodes is working on now, like global planner, local planner, and the behavior tree, the behavior server, the control server, so the smoother planner, so the AMCL, the map server. These are the nodes is connected on only nodes and the topics. Okay, and now we get the navigation area in ROS, right? So now we have the map information, sensor information, TF information, and the global local planner values, and also the initial position of the robot by using AMCL algorithm to post estimate the robot in the initial location. So these many information is available to do the Nav2 Nav2 process. So then for giving the goal location, we need to make use of this ROS2 no goal to give the location from A to B location. Now the robot is initialize its location from initial location to the goal location. We need to use this Nav2 goal thing. So after giving this, you may find out that the path is created, and also the some arrow marks is created in between the robot area to the goal area. So these arrow marks is green color is all over the localization part, and then this is like cell decomposition method, like it will be pull the robot from the obstacles. So once again I will make the new path and will identify that how it's working the planner thing. So now I am publishing new location. So here you may find out that some new arrow marks is created in the path. So these arrow marks is identifying the obstacles using a global local planner thing. So and it will be pull the robot from the obstacles. So that's a process of these arrow marks. So then now is an initial position, and we place the goal location from initial location to the goal. So the robot will be navigate from the A to B location using this. So now we understand how the navigation is working on the ROS2 version. So then we'll start with an simulation in Gazebo, and then how to do the mapping using a cartographer and the SLAM toolkit. And now we use the bring up Nav2 to do the navigation. Then we'll start with an web UI control for ROS 2 using a ROS bridge version of ROS. Then we'll start with an navigation to build the planner behavior, a smoother server or behavior tree server to make the robot to move in navigation thing. And we'll enter that hardware part using Jetson or Raspberry Pi to make the robot from the scratch in ROS and the ROS2 version. It's an upcoming video tutorial. Okay, please subscribe the channel. Thank you.